So this question says both Mrs. Thomas and Miss Murphy drink a soda with 130 milligrams of caffeine. After each hour, the amount of caffeine in the body diminishes. So the equations below show how the caffeine diminishes in each person. So the equation for Mrs. Thomas is C of T is equal to 130 times 0.888 raised to the T. And for Miss Murphy, it is C of T is equal to 130 times 0.65 raised to the T. Now, the question that we're answering is in whose body is the caffeine diminishing quicker, or whose body is the caffeine leaving the body quicker? And in order for us to answer that question, we need to find a decay factor for each of these teachers. So the decay factor for Miss Thomas is 0.888, and the decay factor for Miss Murphy is 0.65. And we want to go back to like the general form of the exponential equation, which is y is equal to a times b to the x, where our initial value is 130, right? Because they both started with 130 milligrams, and our decay factor is b. So for Mrs. Thomas, it's 0.88, and for Miss Murphy, it is 0.65. So the question we're saying, in whose body is the caffeine diminishing quicker? Well, if we look and examine these numbers, we can carefully see that 0.88 is a higher number than 0.65. And what that means, if that is the remaining value of caffeine in each person's body, it means that Mrs. Thomas would have more caffeine in her body by the hour than Miss Murphy. So the question that we're answering is, whose body is the caffeine diminishing quicker in? And so the caffeine diminished quicker in Miss Murphy's body because she had a lower decay factor than Miss Thomas. So she had less caffeine in her body over time. This number 0.65 is a smaller number than 0.88 than Mrs. Thomas. So we would say that the caffeine diminished quicker in Miss Murphy's body because she had a lower decay factor than Mrs. Thomas, or when you check it out, she has a lower remaining value of caffeine in her body than Mrs. Thomas.